Here are solutions to the polynomial multiplication worksheet. The first one here, we have two monomials that we're multiplying together. Let's see, what are we doing here? I think the easiest way to think about this is really what I have written above is the same as this. This is just negative 2 times x cubed times 3 times x to the fifth. And since multiplication commutes, doesn't matter what order I write all this stuff in. So it's perfectly fine to write it like this. But maybe this is a form we can evaluate. Negative 2 times negative 3 is negative 6. X cubed times x to the fifth is x to the eighth. Let's see, maybe I'll make a little note over here. Note x cubed times x to the fifth. X cubed is just x times x times x, and x to the fifth is just x times x times x times x times x. So if I want to multiply this times this, really all I'm doing is multiplying x 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So I get x to the 8th over here, which explains where this x to the 8th came from. Anyways, down to part B, x to the 10th times x to the 20th. We can do something similar to this, although it'd be kind of annoying to write out x 10 times and then 20 more times. But if you kind of just think about what happens, it ends up being x2. You end up adding these numbers together, right? We'd have 10 of them, then 20 of them, so we'd have 30 in total. So x to the 10th times x to the 20th is x to the 30th. All right, multiplying a binomial, or multiplying two polynomials, but neither of them are monomials this time. I think the best way to do that is this box method that we talked about. Yeah. Right, one of the polynomials going down, the other one going across. And then you create a box. Or I suppose a lot of boxes, kind of a grid. And what you do is just fill in each of these boxes. So what goes here is x times x cubed, which is x to the fourth. Goes here is 2x squared times x, which is 2x cubed. X times 4x is 4x squared, and x times 8 is 8x. Negative 2 times x cubed is negative 2x cubed. Negative 2 times positive 2x squared is negative 4x squared. Negative 2 times positive 4x is negative 8x. And negative 2 times 8 is 16. And now what we have to do is add up this plus this plus this plus this, this, and this. But what I want you to notice is when we're adding these up, those two will cancel, those two will cancel, and those two will cancel. So really I can kind of shortcut this and say that all I'm going to have left is this x to the fourth right here and this negative 16 at the end there. So my answer ends up being this. All right, here's one, same method, but I think this time things won't cancel out so nicely. But we'll do the exact same thing, right? This polynomial going down, this one going across. Doesn't really matter which one you choose to go down and which one to go across, in case you were wondering. And then I'll make my boxes. So if I put the lines in something like this, I end up with a grid. We're going to have 9 boxes this time. But since we're pretty good at multiplying monomials, we can kind of fly through them. 2x squared times x squared is 2x to the fourth. X squared times negative x is negative x cubed. X squared times 1 is just x squared. Negative 4x times 2x squared is negative 8x cubed. Negative 4x times negative x is, what, positive 4x squared. Negative 4x times 1 is just negative 4x. And finally, 5 times 2x is 10x squared. 5 times negative x is negative 5x, and 5 times 1 is 5. So we have all this mess. Let's see, this is equal to 2x to the 4th. Now I'll write my x cubed terms, which we got negative x cubed and negative 8x cubed. My x squared terms, I got plus x squared, plus 4x squared, and plus 10x squared. I'm kind of running out of room. Maybe I can squeeze it in. My x terms, I got negative 4x and negative 5x. And finally, my constant term, just the plus 5 over here. And if I combine like terms, I only have 1 x to the 4th. Well, 2, but only one term, 2x to the 4th. See, negative 1 x cubed, negative 8, and negative 1 and negative 8. These are the only two with x cubed. So negative 1 minus 8 is negative 9 x cubed. X squareds, I got 3 of those. 1, 4, and 10. So let's see, that's 5 and 10, which is 15 x squared. Negative 4x and minus 5 more x gives us minus 9x, and then finally plus 5. All right, another one of these. Maybe a little bit overkill, but put it on the worksheet, so I guess I should do it. 5x to the 5th plus 3x cubed plus x minus 5 times 2x cubed minus x plus 2. Make a grid. What are we going to have? 12 boxes this time. Probably a little bit more than I'd have you do on a quiz. But for a worksheet, maybe I can get away with it. So 2x cubed times 5x to the 5th is 10. X to the 3rd times x to the 5th, x to the 8th. 2x cubed times 3x cubed is 6. If you multiply the coefficients, x cubed and x cubed gives us x to the 6th. 2x cubed and x gives you 2x to the 4th. 2x cubed times negative 5 is negative 10x cubed. Don't let the sound of dishes being done in the background distract you. 5x to the 5th times negative x is negative 5x to the 6th. Negative x times 3x cubed is negative 3x to the 4th. Negative x times positive x is negative x squared. Negative x times negative 5 is positive 5x. And 2 times 5x to the 5th is 10x to the 5th. 2 times 3x cubed is 6x cubed. 2 times x is 2x. 2 times negative 5 is negative 10. So then finally, our answer over here we're going to get by adding all this mess together. Maybe I'll save a step and I won't write all 12 of these terms. I'll just collect like terms right now. So the only place where I got x to the 8th is this first guy. I got 10x to the 8th. Let's see, where my x to the 6th? It looks like I got some here and here. So 6 minus 5 just leaves me with 1. X to the 6th. X to the 5th looks like it just shows up right here. So 10x to the 5th. About x to the 4th. Got some here and got more here. So that's positive 2 minus 3 is net of negative 1. X to the 4th. Getting a little ridiculous. Negative 10x cubed, positive 6x cubed. That nets out to negative 4x cubed. X squared. So it looks like I just got them right here. Negative x squared. X's, got them here and here. 2 and 5 is 7. X, finally, minus 10. So this monster, this huge mess is our answer. All right, finally. Moving on. This guy, x plus cubed, x plus 3 times x minus 3. We can do it the exact same way we've been doing it. Although what you'll see in the next section is this is a kind of a special form of polynomial multiplication, and there's a shortcut to do it. But for now, since we don't know the shortcuts, we'll just do it. X times x is x squared. X times 3 is 3x. Negative 3x times x is negative 3x. And negative 3 times 3 is negative 9. But what I want you to notice is that these and these will cancel out. And what we'll be left with is just x squared minus 9. So kind of what, if you look back up at the problem, sort of this x times this x gives us the x squared, this 3 times this negative 3 gives us the negative 9, and everything else cancels out. This right here is called a difference of squares, and these are called conjugate pairs. And when you have something plus something and then something minus something, there's a little shortcut to get the answer. But again, you don't have to know that shortcut. I'm just showing you. You'll see it in the next section. This next one, we could use the shortcut right away, but I won't because I'll assume you don't know it. So I'll go through, and I'll do it the exact same way we've been doing stuff. 2x times 2x is 4x squared. 2x times 5 is 10x. 2x times negative 5 is negative 10x. 5 times negative 5 is negative 25. So again, the 10x and the negative 10x cancel each other out. And what we're left with is just 4x squared minus 25. And so kind of like this x squared minus 9 was this minus this, or sorry, this squared minus this squared. This guy is this squared minus this squared. But again, that's something we'll see later in this chapter. All right, just a few more. X minus 5 squared. All right, what makes this hard is people try to look for a shortcut in here, but there really isn't one. You might want to try to distribute this squared down and call it x squared minus 25 or plus 25 or something. But it turns out that doesn't work. Something squared means that something times itself. So what we want to do is set up a table like we've been doing these. You'll see that there is a little bit of a pattern for doing these, but I don't know that it saves that much time rather than just setting up our box method. X times x is x squared, x times negative 5 is negative 5x, x times negative 5 is negative 5x, negative 5 times positive 5 is, negative 5 times negative 5 is positive 25. So what we get is the x squared, and then we have these two, so negative 5x minus 5 more x is negative 10x, then plus 25. So be careful, it's tempting to call this x squared plus 25, but you'd be wrong. You need this negative 10x in the middle. Comes from these guys. A few more that kind of look that same way. 3x minus 2 squared. Remember, that's 3x minus 2 times 3x minus 2, similar to the last one. Get 9x squared minus 6x and plus 4. Put it together, you get 9x squared minus 12x plus 4. What if this wasn't a negative and if it was a positive? Well, maybe you can just kind of look up at this one. I mean, you could set up the boxes all over again, but it'll turn out it'll be really similar. The only difference is we'll have a plus here instead of a minus. Right? If this was positive and this was positive, these both would have been positive 6x's. So positive 6x and 6 more x gives you 12x. You get here. And finally, these last two, x cubed to the 5th power. The way I think about that is it's x cubed times x cubed times x cubed times x cubed times x cubed. Right? We want 5 of these things. We're raising it to the 5th power. And each of these are x times x times x. X times x times x. X times x times x. Should have chose a smaller number. But really what we have here is 5 sets of 3 x's, but these are all getting multiplied together, so I ended up with 15 of these x's down here. So my answer is x to the 15th, or if you want to see it in rule form, really if you have x raised up to an exponent raised up to another exponent, what you do is you multiply those two exponents. This is called the power rule. Alright, what we got over here, kind of the same idea, 2x to the 5th cubed. Well, let's see, this is 2x to the 5th times 2x to the 5th times 2x to the 5th. Multiplication commutes, so I can write this in any order I want. So I could write it like this. Oh, that's supposed to be a 5 at the end there. Maybe I'll try again. 2 times 2 times 2 is 8. X to the 5th times x to the 5th times x to the 5th Turns out it's x to the 15th. You could think about this as 5x's, 5 more, so you get 15. You can think about it as this rule. You could think about it using our, what I guess maybe the book calls this a product rule. But you kind of have to do it twice, first with these two, and then with that answer and this one. Maybe I'll put a box around here. These are what the book would call your rules, but they're easy to confuse. So rather than memorize, I try to sort of understand why they are what they are. But at any rate, that gets you all these answers, and that finally is the end of the worksheet.